Hello everybody, welcome back to another video. Today we're going to be solving FRQ number 4 for the AP Calculus BC 2025 FRQ. If you just got done with the exam, you can check your answers. Let's get right into it. Alright. The continuous function f is defined on the closed interval -6 is less than equal to x, which is less than equal to 12. The graph of f consisting of two semicircles, right here, and one line segment, right here, is shown in the figure. This is our figure. Analyze it for a second. Got it. Graph of f, don't make sure it's not f prime or anything. Now, let g be the function defined by g of x is equal to the integral from 6 to x, 6 is very important, of f of t dt. Part A, find g prime of 8. Give a reason for your answer. And this is no calculator. So, if you are practicing for the 2026 AP Calculus BC exam or AB exam, I recommend pausing the video. But if not, then let's get right into the solution. So, part A. First off, before we find g prime of 8, let's find g of 8 itself. It can't be too bad. G prime of x is going to be ddx of g of x, which is equal to ddx of the integral from 6 to x of f of t dt. Now, this 6 does not matter, and whatever function this is, if it's x cubed, we would simply plug that into the f of t, so it would be f of x cubed, multiplied by 3x squared, the derivative of x cubed, because the derivative relies on the chain rule, on the bounds especially. But because this is x, the derivative of x is just 1, which means that the ddx of the integral from 6 to x of f of t dt is just equal to f of x. So g prime of x is just equal to f of x, meaning g prime of 8 is equal to f of 8, which is equal to, what is f of 8? Right here, 1. Simple, can't mess it up. Now, one part of this question was give a reason for your answer. And I found this very strange because College Board doesn't typically ask that for a very straightforward problem like this. What I decided to write on my calculus exam was that g prime of x is simply equal to the derivative of the integral of from 6 to x of f of t dt, and by definition, that is f of x. So I kind of wrote this out in word form. And then the reason for my answer was that because that is true, g prime of 8 is f of 8, which is just 1. Hopefully College Board doesn't need an English answer for that, because I'm not sure if many people put that on there, but the math might be sufficient. This could be a valid answer. Now, part B. Find all values of x in the open interval -6 is less than x, which is less than 12, at which the interval of g has a point of inflection. Give a reason for your answer. The reason is very applicable here, and we'll see why. Now, let's analyze this carefully. Find all values of x. We have to realize that this is an open interval, and they're looking for when g has a point of inflection. A function has a point of inflection when the second derivative is equal to 0 at that point, and it changes sign. It has to change sign. So let's take a closer look. So when does g double prime change sign? Let's find out. G double prime can be defined as such. The ddx of f of x, which for simplicity, I'm just going to write f prime of x, just like that. So we're looking for when f prime of x changes sign. We can analyze the graph carefully. This is the graph of f, which means at this point onwards, the graph is decreasing, that's for sure, which means the derivative is going to be negative. So I just like to write this right here. F prime is less than 0 because the function is decreasing here. Then all of a sudden at this point, onwards till about here, the function is increasing. It's going like this and this and this. F prime is greater than 0, and then f prime becomes negative here. F prime is less than 0, then f prime is just a constant, is equal to c, because it's the same linear slope. Now, what can we do with this? We want to know when f prime changes sign. F prime is negative here, it's positive here, it's negative here, and it's positive here, which means that f prime changes sign at this point, and it changes sign at this point, and changes sign at this point right there. Those are the 3 points which are candidates for the points of inflection. So it goes from negative to positive. Just to verify, always double check that you didn't miss anything, because it's easy to overlook all of this. But yeah, we got 1, 2, and 3. Okay. All you have to do now is just write out those x values. So those x values were x equals -3, x equals 3, and x equals 6. And the justification is because g double prime of x equals f prime of x, that's part of the justification, and changes. This changes sign. And you can also write, if you want to be more specific, but you don't really have to, f changes sign, or not changes sign, but f changes from increasing to decreasing. And, increasing to decreasing. And for sake of simplicity, and vice versa. Because if you analyze it carefully, it's not just changing from increasing to decreasing, but it's also changing from decreasing to increasing. So yeah, that was part B. You have to analyze the points of inflection. Part C. Find g of 12 and g of 0. Label your answers. Very simple. It's just plugging it into the function g. Beware of the little 6 here. Many people got confused when they saw that. We can find, first off, g of 12. Let's start with that. G of 12 is equal to the integral from 6 to 12 of f of t dt, which is going to be equal to what? We're integrating from here all the way to x equals 12 of f of x. This is just finding the area under the curve because that's the definition of integration. And this is just a triangle because it has a linear slope right here. So the base is going to be equal to what? 12 minus 6, which is 6 in the bottom. What is this height equal to? 3 units, and that's all we need. So it's going to be 1/2 base times height. 1/2 6 times 3, and this is going to give us 9. Now, they wanted us to find g of 0. What is g of 0? G of 0 is going to equal the integral from 6 to 0 of f of t dt. I don't like having a lesser number or a number that's less on the top bound, so I'm going to reverse the integral bounds by pulling out a negative. So g of 0 is going to equal negative integral from 0 to 6 of f of t dt. And now we can use some logic just to solve this. We want to solve from 0 to 6. 0 to 6. And we're told in the problem statement that these are two semicircles. Semicircle is just 1/2 pi r squared, half a circle. So what is our radius in this case? From 3 to 6, this radius is going to equal 3, which means our area is equal to 1/2 pi r squared, which is 1/2 pi 3 times 3 squared. It's that simple. And now don't forget our negative sign, which means our answer for this integral is going to equal negative 1/2 pi times 3 squared, which is going to be negative 9 over 2 pi. But you do not have to simplify because it is AP Calc BC, and you don't have to do that for the College Board exam. Now, we have the hardest part where many people got tripped up, but this is part D. I will add another page. Let's go for that. Okay, part D. My part C got a little cut off, I think. Yeah, that's all right then. Let's bring it up. All right. Now, part D. Part D asks, find the value of x at which g, our integral from 0 to 6 to x, attains an absolute minimum on the closed interval from negative 6, which is less than equal to x, which is less than equal to 12. Justify your answer. So, what we have to do is analyze g prime of x. We can't tell when g attains absolute minimum because we have to look at the derivative of the function. Because once again, in my other videos, I'm sure you're aware, if you look at the derivative is equal to 0 whenever there's something you can test for a minimum or a maximum, some relative or absolute minimum or maximum. That's how you find your critical points. So, what is g prime of x? G prime of x is equal to f of x. And let's find for when g prime of x is equal to 0, or when it changes from negative to positive. Because what do they want? They want their minimum. When a function changes from decreasing to increasing, that's when we know there's a minimum right there. So let's analyze all of our points. When is this going to equal 0? It's going to equal 0 when f of x is going to equal 0. So our potential candidates for when g of x is minimized are negative 6, 0, 6, and there's one more point. Pause the video if you want to find it, but if you got it, it's going to be x equals 12, because you always have to consider your endpoints. Even if the function weren't crossing the x-axis at that point, or equals 0 at that point, we would still have to consider negative 6, because that is very it's very fundamental to how we test endpoints and find critical values. Those endpoints are critical values as well. So, moving on from there, let's simply do so. We have, I'll make a little table, which makes it a little easier. X negative 6 g of x, and our other value is 0, and our other value is 12. Now, what is g of negative 6 going to equal? Let's see if we solved it earlier. Did we solve it earlier? No, we did not. So that means we're going to have to do it from scratch. G of negative 6 is going to equal the integral from 6 to negative 6 of f of t dt. G of negative 6, I'm going to swap the bounds because I like just to do that. It makes it easier to conceptualize, of dt like this. So let's find this integral, negative 6 to 6. Now I'll use purple. Negative 6 is right here, 6 is right here. We already found that area. That's going to be 1/2 pi times 3 squared. How do we find this area? Well, it turns out it's the exact same thing, but just look at it a little more carefully. Right here we have this value, and to here, this gives us a radius of 3. We're trying to find this area. But you'll note, this is under the x-axis, which means that it is negative by definition. So this turns out to be the exact same area. It's going to be negative 1/2 pi times 3 squared. The negative is only because it's under the x-axis, and it has the same radius and everything else. So if we put this back into our formula, this gives us g of negative 6 is going to equal the negative right here, we're carrying this down, of, let's sum those values from negative 6 to 6. 1/2 pi times 3 squared, and we also have to add this part, which is also part of the integral, minus 1/2 pi times 3 squared, which turns out to be 0, which means g of negative 6 is going to equal 0. Equals 0. This is going to, now we can move on forward to x equals 0. G of 0, we already found the answer to that, I believe. Yeah, we did. It's going to equal negative 9 over 2 pi. Negative 9 over 2 pi like that. That is less than 0, so that is a potential candidate already. Now, g of 12, what do we find g of 12 to be? It's equal to 9. That's quite high. That's more than 0 and negative 9 over 2 pi. Now, we considered all of our endpoints except for one. There's one left. X is equal to 6. Let's see what happens at x equals to 6. And I didn't put in the table here for a reason, but we'll see. X equals 6. G of 6 is equal to the integral from 6 to 6 of f of t dt. I plugged in the 6 because it was 6 to x, and this causes our integral to just become 0, just like that. Now, if you really want to be technical, you could add it to the thing, but it's not really a relevant point. And it's usually when you see a sharp turn like this, you'll know something weird is happening around there, but that's not why something weird is happening. It's just because the integral turns out to be 0 at that point. So we tested all of our 4 main points, and I'll write that's equal to 0 right there. And you can clearly see which one is our minimum value. Our minimum value occurs at x equals 0, and the minimum value itself is negative 9 over 2 pi. So you can simply write, let's see if we're missing any part. They want justification, oops, not Siri, but they want justification why this is the minimum value. And they want the x value for which g attains absolute minimum. That x value is going to be x equals to 0. So we can say absolute minimum, or g's absolute minimum occurs when g prime, I'll write equals f because that clarifies what we're doing, changes from negative, and this is evident on the graph, negative to positive at x equals 0. They did not ask for the minimum value. So if you get this, put that on there, you might confuse them, and they might be thinking you gave the wrong answer. They asked you only for the x value. Do not give anything more than that. Yeah, and make sure you say absolute minimum. If you say relative minimum, that's an issue because they asked for absolute. But yeah, once you got that, you would have basically full scored the FRQ. You got your absolute minimum, you got g of 0, g of 12, you got the points of inflection, get your x values in there, and simply get everything right. Yeah, simple enough. If you have any questions, if I didn't explain anything simply enough, if I complicated something, let me know. If you have future video ideas, let me know. Drop a like, follow, subscribe, share. Thank you guys so much. Have a great day.